Hello.
Good morning, sir.
Good morning. Okay, so
Good morning, sir.
good morning. Okay, so last class what we have discussed, let us start today. Okay. Okay. So if I start today, last class, what were do you have any doubt in last class or everything all right?
Yes.
ঠিক আছে?
স্যার
হ্যাঁ বলো।
আপনি বললেন না আমাকে একটু এই বাটারফ্লাইটা একবার বলে দেবেন?
কোন বাটারফ্লাইটা, ডিআইটি না ডিআইএফ?
না স্যার, এই এফএফটি এর ইয়েতে আপনি একটা পাঠিয়েছিলেন পিডিএফ, ওইটা।
আমি তো অনেকগুলো পিডিএফ পাঠিয়েছি এফএফটি তে, একটাতে তো বাটারফ্লাই দুটো আলোচনা
লেকচার
করে।
32 স্যার।
লেকচার 32?
32, হ্যাঁ।
32 তে তো ডিআইটি এফএফটি বোধহয়।
যাই হোক, মানে ওইটা আর কি।
তো ওইটার বাটারফ্লাইটা কি সমস্যা?
না মানে স্যার, সমস্যা নেই, মানে ওইটা থেকে একটু বুঝিয়ে দিন আর কি। যে আমি তো করিনি ফার্স্ট ক্লাসটা, তো কি করে ক্যালকুলেশনটা কি হচ্ছে বুঝতে পারছি না।
আচ্ছা, লেকচার 32, লেকচার 32 মানে আরো উপরে, আরো উপরে ডিআইএফ আর ডিআইটি। 32 মানে লেকচারটা এইটা, এইখানে, এইটা বুঝতে পারছো না তো? এইটা যদি দেখো,
হ্যাঁ
এটা
হ্যাঁ হ্যাঁ।
তো এখানে দুই।
Good morning, sir.
গুড মর্নিং, গুড মর্নিং। এখানে 2 আছে x0, 2 এখানে x4 আছে, তাই না? W20 এর ভ্যালু কি? W20 ভ্যালুটা হচ্ছে 1। তাহলে এইখানে যখন আসবে তাহলে কি হবে? x0টা এখান থেকে এলো, x4টা এখান থেকে এলো, তাহলে এটা 2, এটা 1, তাহলে এটা 3 হয়ে গেল। আর এখান থেকে 2 এলো, এখান থেকে 1 এলো, 2 1 1, 2 1 মানে হচ্ছে 1। বুঝা গেল? তারপরে
আচ্ছা
next what you have to do, x2 equal to 2, x6 equal to 1, you have to add these two, it will come here 2 plus 1 here, and this is 2 minus 1, this will be here, like that. Like that, all this you can see same thing. Now if you come this at this stage, then this will be equal to 3 multiplied by 1, so this is 3 and this is 3 plus 3 equal to 6. Then if you look at here,
হ্যাঁ হ্যাঁ
1 and this is equal to minus j, so this is 1 minus j. Now if you come here, this is your 1, this is j but into minus 1, so this will be plus j, this will be 1 plus j, like that everything. Okay, now I hope you understood.
হ্যাঁ হ্যাঁ।
Bas ঠিক আছে। Anybody having any more doubts in this, right? Regarding DIF FFT, anybody having any doubt? No doubt, everything all right?
Yes, sir.
Very good. Then we'll today see the some what do I call that, if I want to see that this is the 8-point case I have solved. Basically this FFT algorithm that is actually reducing the computational complexity, and that could be applicable to any endpoint sequence, right? Any endpoint sequence. So first endpoint sequence will be decimated into n by 2-point sequence, then n by 4-point sequence, and we'll compute DFT only when it is a 2-point sequence. With the process of doing this, what essentially we have achieved, reduced multiplication computational complexity, which means lesser number of multiplication and lesser number of addition. All right, now my question that I have taken the example for 8-point DFT. Now today I will take one example of 4-point DFT. 4-point DFT could be solved using the same process, is not it? because 4-point DFT again you can reduce to 2-point DFT, then you can compute like that. So suppose this is signal x of n 1 2 3 0. This is a 4-point sequence and I have to compute 4-point DFT, right? This is possible because length of the signal is 4 and 4-point DFT I have to compute, so n less than equal to 4, so 4 equal to 4, so we can do that. Now for this particular problem, DIT FFT, so n equal to 4, n equal to 4 means 2 part 2, 2 part 2 means you require number of stages is 2. Now in DIT FFT, if you remember that input is bit reverse order, agreed?
Yes.
Fine. Therefore, what is the normal order of the sequence? x0, x1, x2, x3, 0 0 0 1 1 0 1 2. Then I have to make it bit reverse. So this is 0 0, this is 1 0, this is 0 1, this is 1 1. Then this will be x0, x2, x1, x3. So bit reverse order of the sequence will be x0, x2, x1, x3. So x0, x2, x1, x3. This is the bit reverse order, right? Then what
Yes.
is there in the structure? You have to connect this two, you have to connect this two. Then first case you are having W20. Is not it? That is in the previous diagram, right? This W0, you have to compute that. Then if you take 1 2 3 0 means it will be 1 3 2 0 because x0, x2, x1, x4 I am computing DIT FFT. If I am computing DIT FFT means I am computing decimation in time. Decimation in time means input is in bit reverse order, output will be normal order.
Normal.
Therefore, now if I compute this, then this will be G1 plus 3, this is 4, and this will be 1 minus 3, this will equal to minus 2, like that. 2 plus 0 equal to 2, and 2 minus 1 0, this is 2. Now next stage you are having W40 and W41, like that. In previous butterfly diagram, whatever there, that is same thing. Now W40 and W41, then what happened? Then this I have to compute in the 0, right? This I have to go there, and this we have to take into this line, and this line will come here, and this line will come here. That is as per the previous diagram. So what is there? First you have to compute this individual section, then you have to connect this to individual section. How to connect? This lower to this upper line goes to upper line, this lower line goes to this lower line, right? This upper line come to this upper line, this lower line come to this lower line. This is the basic principle of preparing butterfly diagram. And I said when there is a multiplication factor, you should write -1 in that. When there is a multiplication factor, we will write -1 here. So this is the diagram. Now if you write 4 and this is 2, this becomes 6, this becomes -2 minus 2j, and this is 4 and this is 2. So this is 4 minus 2, this is 2, and this is say this is your -2, this is your -2, and this is W41. W41 equal to minus j. So j into -1 means plus j. So this will be equal to -2 plus 2j. Therefore, the result of this is x0 equal to 6, x1 equal to -2 minus 2j, 4 minus 2 equal to 2. This is -2 minus 2j. Now this is the computation of 4-point DFT using DIT FFT algorithm. Is it all right?
Yes, sir.
All right. Now you compare whether this is easier or this method is easier. Previously, what we have done, xn means x0, x1, x2, x3, this 4 value. Then xk computation x0, x1, x2, x3. Then all this one, this is W41, W42, W43. Then W42, W44, W46, W43, W46, and W49. All right. This is how to write this matrix. This matrix is corresponds to this two ideal factor, W and Nk. Right. This I have discussed in detail. Now you can write these values from the basis of this diagram. W40 and this there. That will be -j, -1, -j, -1 plus 1. This is corresponds to W44. Okay. So this way you can fill up this rest of the matrix W41, W42, W43 up to W49. Then if you fill up this, then if you multiply, this will be again 1 plus 2 plus 3. This is if you multiply this row with this column, this will be 1 into 1, 2 into -j, and 3 into -1. So this will be like this. And next column, if you multiply, this will be 1 into 1, 2 into -1, 3 into +1, and 0 into -1. This will be equal to this. and 0 if you multiply, then okay. So all right. Okay, so
Yes.
if I write 1 into 1, 2 into j, and 3 into -1, and 0 into j is 0. So if you write this result, this is like this. Therefore, whether you compute using this algorithm, and if you compute using this algorithm, both are having the same result. Now, which method is simpler?
Butterfly.
Huh? Butterfly, you can
Butterfly.
Butterfly.
if you compute even more quickly. But the thing is that people used to neglect this section because this seems little difficult algorithm approach, but solving problem is much easier than this in the conventional methods, right? These 4 lines you draw, like you write the signal in bit reverse order, then you simply add, you can get this. So this calculation is much easier, and this calculation is easier for somebody, those who can remember this value, or they can draw this, what you call the quadrant, and write this quickly. But still, I do believe that calculation involved in butterfly is much less compared to this. But if you solve either of the way, you can get the same marks, not an issue. So choice is yours, but both the answer will be the same. Okay. So if you have understood this, so this is one example in which I have solved 4-point sequence, or of the 4-point sequence, and at the same time I am computing 4-point DFT. Right. This is one problem. I have asked this question in assignment, right? For 4-point sequence, what will be the input order and all this? This kind of question you can expect is a short question, right? So this is one approach. The next thing I want to discuss is how to compute IFFT using FFT algorithms, right? And how to compute inverse Fourier transform, inverse first Fourier transform using butterfly structure. That means using algorithms, inverse FFT, that is I mean IFFT. What will be the corresponding modification in the butterfly structure, and what will be the detail, right? But at the same time, I don't want to waste much time in this, because this is very simple. If we have understood DIT-FFT and DIF-FFT, then you should be in a position to do very quickly an IFFT. So what is the theoretical modification that I will discuss in very short time? Let us come into that. Of course, I will give one example so that you don't have any ambiguity. You should have a very clear understanding on that. Let us see that. X of k, n equal to 0 to n minus 1, x of n e power minus j 2 pi n k. This is the equation of DFT. This is n point DFT due to this n, right? And the length of the sequence, that could be at most n. So this is n equal to 0 to n minus 1, right? This is the understanding of this equation. And also k will be varying from 0 to n minus 1. This is what this equation is. This could be written n equal to 0 to n minus 1 xn wn n k. Regarding wn n k, I have said many times. Let's look into that. W equal to e power minus j 2 pi, and wn equal to e power minus 2 pi by n, and wn n k equal to e power minus j 2 pi n k. I have discussed it many times. But the one important thing that I want to mention in this stage, suppose sometime it happened, question comes, then what is the amplitude of the tidal W? That means W. What is the amplitude of this? The amplitude is 1. All right, amplitude of W is 1, and phase of W is minus 2 pi. This is also a question, short question, many times it is asked. What W, what is the amplitude and phase? Amplitude 1, phase is just 2 pi, minus 2 pi. Okay, now coming back to this equation, that this is the equation of DFT. So what we have done in DIT-FFT algorithm, we have implemented these equation by means of some sections. This is an endpoint DFT. This particular equation I have decomposed into n by 2-point DFT, and then we have decomposed into n by 4-point DFT, and so on and so forth. Therefore, essentially, we have computed this particular equation in DFT. DFT, essentially, we have started with this equation, then we have got n by 2-point DFT, then n by 4-point DFT, Then we have implemented this in two different kind of problem. Suppose for 4-point DFT, we have implemented up to n by 2. For 8-point DFT, we have implemented up to n by 4. Agreed? Agreed?
Yes.
Yes. Therefore, what I mean that whether you talk of DITFFT or you talk of DIFFT, essentially we have computed this particular equation in terms of algorithm, and thereby we have reduced the computational complexity, because this equation is the fundamental equation which is used for computation, right? Because this is the equation of DFT and we cannot neglect this. And this equation derived from x of k equal to n equal to 0 to n minus 1 x of n e power minus j 2 pi n k by n. Where from it is derived? It is derived from which equation? Which equation?
Z transform. R equal to 1 is
R equal to 1 z transform. Then R equal to 1, what is this transform? You are correct. R equal to 1, then okay. Z transform R equal to 1, then what is that equation? In Z transform equation, if we put R equal to 1, what is the name of this equation? Name of the equation? What is the name of this equation? Z transform R equal to 1. What is the name of the equation? Z transform R equal to 1. What is the name of the equation?
unit circle.
Unit circle. All right. What is the name of the equation?
Fourier transform.
Fourier transform. Discrete time Fourier transform. DTFT. Right. Remember? That is DTFT. Then this is equal to x of n e power minus j omega n. Then omega we have replaced by omega k. So x of z n equal to minus infinity to infinity x n z power minus n. This is your z transformation. Then z equal to r into e power j omega. Then if you substitute r equal to 1, it will be equal to x of n e power minus j omega n. So x of n e power minus j omega n, this is called discrete time Fourier transformation. Agreed? I hope it's all right. Then
Yes.
omega will be replaced by omega k, which I am writing k, which is equal to 2 pi by n into k. 2 pi by n into k means n number of points in the unit circle, in the Fourier domain. That is how this equation is derived. Now DTFT and DFT, what is the difference? DTFT frequency domain is continuous, DTFT, and we have seen that x of omega or x of e power j omega, that is periodic with period 2 pi. All right, that we have discussed all these things. So therefore this equation is derived from discrete time Fourier transformation, which is known as DTFT, and this equation is known as DFT. DTFT, time domain is discrete. In DTFT, time domain is discrete, but frequency domain is a continuous function of omega, and this is periodic with period 2 pi. And when this frequency domain is discretized, then we got this equation. This is called discrete Fourier transform. Okay, this is called discrete Fourier transform. Okay, this is called DFT. Now this DFT is periodic with period n, correct. This DFT is periodic with period n. N point DFT is periodic with period n. N by 2 point DFT periodic with period n by 2. N by 4 point DFT will be periodic with period n by 4. All right. These are the things we have discussed. Now we are writing that inverse DFT, that is called equation of IDFT. This also I have derived, and it is xn equal to 1 by n, k equal to 0 to n minus 1, x of k e power j 2 pi k n by n. What is the difference between these two? Xn is what I have written, x of k, and this is negative. This is
This
positive.
is positive.
Another difference is this is 1 by n. This is the three difference. Otherwise, these now if we compare these two equations, what is the difference? The difference is this is negative, this is positive. One difference. Another difference is xk xn, that is all right and not an issue. K equal to 0 to n minus 1, n equal to 0 to n minus 1. In that respect, there is no difference because xn, n equal to 0 to n minus 1. Xk, k equal to 0 to n minus 1. In that respect, there is no difference. Only difference is divided by 1 by n and e to the power minus j 2 pi n k. This is the two difference between these two equations. These two equations, mathematical point of view. If you look at the mathematical point of view, two difference. This is positive, negative, this is positive. And this is divided by 1 by n, that is not there. Otherwise, these two equations are identically same. Do you agree with that?
Yes.
Right. For mathematics, mathematical point of view, I'm talking about. Conceptually, these two are hell and heaven difference. One is DFT, one other one is IDFT. So these differences hell and heaven. Right. One is frequency domain, one is time domain. That is different, totally different. But conceptually, that is. But mathematics, mathematically, as a mathematical equation, if I look into this, only two difference. One is this is negative, this is positive. This is one difference. Another difference is this is divided by 1 by n, this 1 by n is not there. Mathematical point of view, this is the two difference. Do you agree with that?
Yes.
All right. Now, so if I want to write this, suppose say plus, I am writing minus and I am writing conjugate. Is it all right? Is it all right? So if I write minus and then put a star, these two equations are identical. Now, this equation I am talking about xn equal to this, and these are identical. This step to this step is okay because this is minus, this is conjugate. Conjugate means conjugate and minus means second negative plus. Therefore, if I write this, suppose say 1 by nk equal to 0 to n minus xk, w and nk star. Then if I write this equation, k equal to 0 to n minus 1, x of k, w and nk star. That's it. Is not it? Therefore, xn equal to ultimately this equation. This equation. Now compare with this again. This is xn, w and nk, n equal to 0 to n minus 1. So this is k equal to 0 to n minus 1 xk. So mathematical point of view, there is this part has no difference. Only thing there is a star and this is 1 by n. This is the two difference in these two equations. Okay. Therefore, what I can conclude that while deriving DIT FFT algorithm or DIF FFT algorithm, in the process of getting x of k from x of n, the equation what we have used, that we have implemented in the form of algorithm. Now, when we are trying to find IFFT using the same algorithm, mathematical point of view, the difference is only this 1 by n factor and this is star. Therefore, if you consider the butterfly diagram, entire butterfly diagram will be valid. Only thing what you have to do, once we get the output, you have to divide it by 1 by n, and wherever there is a phase factor, you have to write this as conjugate. Shall I repeat?
Yes, sir.
So if the equation of DFT and IDFT, if I compare these two equations, basically I am saying that while developing DIT FFT algorithm or DIF FFT algorithm, in order to get DFT x of k from x of n, we have used this equation. And now if I have to develop x of n from x of k using IDFT equation, in such a scenario, if we compare these two equations of DFT and IDFT, it is observed that only this two idle factor wn and k, this part is different, otherwise, and a multiplication factor is 1 by n. Other than these two, mathematically this equation is identical. Therefore, what I am claiming or saying, that entire derivation what I did, that will be valid. Only thing is that my input was previously xn, now my input will be xk. Right? Input was previously xn, n equal to 0 to 1. So that xn I will replace by xk, k equal to 0 to 1, n minus 1. Therefore, basic structure, number of stages, everything remains same. Then what is the modification that I have to do while computing IDFT or IFFT? Then I have to change the phase factor by its conjugate, and whatever output I will be getting at the final stage, in case of IFFT, that will be essentially x of n. So I have to divide this by 1 by n. Okay, then everything will be valid. Is it all right, this argument?
Yes.
Yes.
Very good. Once you understood this, then I will take one example of 4 point. This is easier to solve, that I have taken this. Today I have taken the problem xn equal to 1230, 4 point sequence. Then I have computed the DFT. And after computation of DFT, what I have got? I have got x of k equal to 6 minus 2 minus 2j, 2 minus 2 plus 2j. This was the output. All right. Now, I have to apply this to find the IFFT. If I find IFFT, what will be the answer? X of n? X of n? X of n means what? 1230?
Yes.
Yes. Very good. Now, let us come into that. Then I have to apply this. Then I am computing IDFT FFT. I mean IFFT using DIT FFT algorithm. Now I am computing IFFT using DIT FFT algorithm. And I have given the argument that my all steps will be same. Only thing, I have to replace n by k for the summation aspect. I have to make the conjugate and conjugate of the two idle factor, and whatever output I will get, finally I will divide by 1 by n, because it's a 4 point DFT or 8 point DFT, n point DFT, I have to divide by 1 by n. Now, for DIT IFFT, I have to write this in bit reverse order. Bit reverse order is what? Bit reverse order means for 4 point sequence, I have discussed here. Bit reverse order means x0, x2, x1, x3. This is in time domain. Now I have to write this in frequency domain. If I have to write this in frequency domain, then I will write x of 0, x of 2, x of 1, and x of 3. Agreed? Agreed? Yes. Now, then I do the same thing, like cross I will do, and this is becomes, initially we are having what? W20. W20 we don't write. W20 we don't write because this conjugate is 1, W20 is 1. Right? So we don't write this. Even here what I have seen, if you look at this diagram, this is W20. W20 and W2 star, they are the same thing because this is equal to 1. 1 and conjugate of 1, they are same thing. Is not it? So I have not written it. So I have considered it is understood. So what I did, I have written nothing. Then it's 1, understood. Now if I add this, 6 plus 2, that is the east, and 6 minus 2 equal to 4. Then minus 2 minus 2j, and this is minus 2 plus 2j. Then if we add these two, this will be equal to minus 4. 2j and 2j cancel. And this, if you see here, this is equal to minus 2 minus 2j, and minus 1 if you multiply, minus 2 become plus 2, that is cancelled. This will be 4j. Agreed? First stage of computation, what is the output? Output is 8, 4, minus 4, and minus 4j. This is the output of the first stage of the computation. Okay. Now second stage, what is there? Second stage, if you look at second stage, what is there in 4 point DFT? that is equal to, let us see, W40 and W41. I will make it star. So W40 star, that is 1 star 1. So it is 1 only. So this is W40 star, this is 1 only, so not an issue. But this is W41 star, so this is a problem because I have to write it minus J star and this is equal to plus J. Okay?
Yes.
Now I have to combine this. This is equal to 8. This is equal to 8 and this is your minus 4. 8 minus 4 equal to 4. Agreed? This is coming 8 now and this is coming minus 4. Minus 4 into 1, that is 4. 8 minus 4 equal to 4. And this is 4 and this is coming here 4j minus 4j multiplied by j. This is equal to 4j square. Minus 4j square means plus 4. Agreed?
Yes.
This is 4j, this is plus j, this is minus 4j square. J square equal to minus 1. Minus 1 into minus 4, 4 equal to 4. So this will be 4. This is 4 and this is 4. This becomes 8. And this is your 8 and this is your minus 4 multiplied by minus 1. This is 4 minus 1 means it is plus 4. This is 12 and this is equal to 4 here, and this is equal to 4j square, that is minus 4. Minus 4 multiplied by minus 1, this is equal to plus 4, plus this is equal to, see, this is minus 4j multiplied by j. This is equal to minus 4j square. Minus 4j square mane koto?
plus 4
Plus 4.
Plus 4. Plus 4 multiplied by minus 1. This is equal to minus 4.
Minus 4.
minus
And this is plus 4. This is becomes 0. So what is the output? 4, 8, 12, 0. Now what I said, output xn I will divide by 1 by n, 4. This is equal to 4, 8, 12, 0. So this is equal to 1, 2, 3, 0, your xn. So we have computed inverse FFT or IDFT using FFT algorithm using the same thing. So whatever discussion I have made so far, whatever discussion corresponds to DIT FFT and DIF FFT, they are all valid for inverse FFT as well. Only thing we have to change the twiddle factor. If it is WNNK, then in IFFT it will become WNNK star, and whatever output I will get, that I will divide it by 1 by n. Rest of the thing remains same, right? With that argument, what I can say, whatever discussion other than these two modifications we have done in case of DIT FFT and DIF FFT, they are identically valid for computation of IFFT, and they will be corresponds to IFFT using DIT FFT, IFFT using DIF FFT. Okay, since we have discussed all these things in detail, so we can be in a position to modify those algorithms only with these two modifications: final output divided by 1 by n, and whatever that WNNK is there, they have to replace by WNNK star. All right? Is it all right?
Yes, sir.
Yes, sir.
So with this, I have completed the chapters of FFT. Now next class we will start filter design technique. If you have any doubt, you can ask in next 3-4 minutes, or if you have no doubts, then I would like to conclude today's lecture. If you have any doubt, you can ask.
স্যার বলছিলাম যে ওই যে এই এক্সাম্পলটা দেওয়ার আগে যেটা বোঝালেন ওই জায়গাটা আমি শুনতে পাইনি, একবার বলে দিন।
I have said that, can you okay. So if you look at these two equations, basically we have developed the algorithm DIT FFT and DIF FFT on the basis of these two equations, on the basis of this equation, x of k equal to x of n WNK or either of this. See, on the basis of this equation, I have developed DIT FFT algorithm. Basically DIT FFT algorithm, DIF FFT algorithm, everything based on the basis of these two equations. Or all this discussion which I have made over last 4, 5, 6 lectures on the basis of this equation. This equation was the basis, and this equation was derived from Z transform and DTFT, right? This is DTCDF. Now inverse Fourier transform, this is the equation. Now, if you look at these two equations, then this equation I have written, this is equal to k equal to 0 to n minus 1 xk e power minus j 2 pi k n by n. So this is x of n, this is your IDFT, right? So IDFT, then I am written 1 by n k equal to 10 minus 1 x of k, this star. If I write like this, then this is equal to same, because e power minus j
Yes,
2 pi k n by n star equal to this. Then I have written w n n k star. Then if I write this equation x of k w n n k and this, if we compare these two equations, we'll see that main difference is this is 1 by n, this 1 by n is not there, this is the one difference, and this is conjugate. Otherwise, mathematical perspective, there is no difference, right? I am saying that
Yes.
x of n equal to 0 to n minus 1, x of k equal to 0 to n minus 1. For a mathematician, these two equations are same. We have different argument on the basis of time, frequency, and all this. For a mathematics point of view, mathematical point of view, k equal to 0 to n minus 1 xk and n equal to 0 to n minus 1 xn, these two have no difference in the perspective of mathematics. Mathematical perspective, n equal to 0 to n minus 1 xn or k equal to 0 to n minus 1 xk, there is no difference. Mathematical perspective. For theoretical understanding, there is a lot of difference. Okay, hell and heaven difference. Okay. Now, if I compare these two equations, only difference is the only star operation and 1 by n. Otherwise, everything is same. Therefore, I have said whatever DIT-FFT or DIF-FFT algorithm we have discussed in time domain, which means converting x of n to xk, all are equally valid with these two modifications. And these two modification means whatever output I will get, I will divide by 1 by n. And wherever there is a phase factor Wn and k, right, W41, W40, and W81, W8, whatever, that I will replace by Wn and k star. With this modification, whatever implementation was there in DIT-FFT or DIF-FFT, they are identically valid with these two modifications. And these two modifications, if I apply, then everything will be same. Whatever we have discussed in DIT-FFT and DIF-FFT in connection with getting x of k from x of n, equally valid in IFFT to get x of n from x of k with these two modifications. Agreed?
Yes.
So I hope Ranakia is all right. Okay. So if I assume that you have understood all this, then I would like to close this session with the understanding that we have completed FFT, and FFT I am supposed to take 5-6 lecture, but I have taken 9 lectures on FFT. With this today's lecture, I have conducted 9 classes in FFT and IFFT using these two algorithms, and I have solved at least 3-4 problems, which is justifying 4-point DFT and 8-point DFT. I have completed that, and above all, what I can conclude that if you have understood, then you should be in a position to solve any 8-point sequence or 4-point sequence, DFT, I mean FFT or IFFT, if you understood the entire thing clearly, right? So if you have any doubt, you can ask. Otherwise, I would like to stop this. Okay, so I hope you have understood this.
Yes.
Now, one thing I would like to mention that I have a class again in tomorrow.
Yes, sir.
Tomorrow I have a class. Tomorrow I will start filter design technique. Another important thing I want to mention that Thursday you are having exam in CoCubes.
Yes,
Yes,
sir.
sir.
বলছিলাম
So
ওটাই বলছিলাম
how many of you are in CoCubes here? How many CoCubes?
আমি অরশ্রী
আমি আছি
অরিত্রিয়া
Oritria 3 আর
স্যার অনুদত্ত
অনুদত্ত 4 আর
আকাশ
আকাশ 5 আর 5 জন তো
অনুষ্কাও আছে তো
অনুষ্কা
হ্যাঁ স্যার আমি আছি
আচ্ছা 6 জন। So okay, in such a case I may stop Thursday. I may not take class because
Yes,
you
sir.
have to start exam by 12. You have to
10
start exam, and this is
10
স্যার 10 থেকে মানে 10টা থেকে 1টা
1
অবধি
PM.
10টা থেকে স্টার্ট করতে হবে। You are having 3 hours exam, right?
3 hours. Yes, sir.
Yes,
So
sir.
I will not take class in Thursday, and for Thursday I will take
Yes,
some
sir.
extra class in some other day. Okay, but
Okay.